Hello everyone and welcome to Module 7. In Module 7, we will be getting some hands-on on keeping time and introducing the deep sleep concept. So welcome and let's start with keeping time. I'll move to the next slide. We mentioned that the low P4 doesn't have a backup battery. Yes, it has a real-time clock built within it, but it lacks a battery. So whenever you power it off, it loses time. So whenever you power it, the first thing you need to do is to activate the real-time clock and set it, because immediately you power it, the time that it will start counting from is the Unix time, which is 1st January 1970. So let's go ahead, and to be able to set time, this is a script that we're going to use. Okay, so I have my microcontroller there. This time around we don't need any sensors, we're just going to be using the microcontroller connected to the computer. So the first thing I'm going to do is I'm going to start the Visual Studio Code. And the next step would be to connect the microcontroller to the computer. So I'll go ahead and connect it. Connected. Once again, remember you have to ensure that the light is blinking in blue. We have a green light here and we have the orange light here. I'll go back to the Visual Studio Code and show you. So we have the Visual Studio Code here, and like once again, if you experience this error, the reason why I'm experiencing this sometimes is because I'm changing the microcontroller. Sometimes I use a different microcontroller which connects to a different port. So the first thing would be, like I mentioned, go to command, all commands, project settings, that's COM7, but then we need to make sure, we need to know where the microcontroller is connected to, which port. And to get that, we go to the device manager. So search for device manager at the bottom here. It pops up at the top, click on it. Move down to the ports, click on the arrow to the left, COM7, it says COM7. And once again, yeah, which matches with mine. So if at all that's the issue, you remember I told you connect and disconnect, or you can as well come and say connect once again, and it's connected. Well, I don't know why it didn't connect the first time, but if it fails, go to all commands and connect. That is after verifying that the terminal is reading from the right COM port where the microcontroller is connected. Okay, I will close that. Then now the next step would be to navigate to the folder that has a script for setting the time. So I will navigate. I'll go to all my scripts. We are in Module 7 and there's the real-time clock. Select the folder and then select it. As usual, the first step you need to do is to upload the script. So I will move down at the bottom, click upload, and the first step it will do will be to remove the previous files contained in the microcontroller. So if you have several scripts that you want the microcontroller to operate, then you have to put them in the same folder so that when you upload all of them at the same time. So I've successfully, and because it has a boot file here, immediately I've finished uploading, it quickly started running it. So you see the first time, because of this script here that says rtc is equals to, the print here, so it prints the current time before setting it, and in the rtc.init, that's the type where we set. And if I look at my watch right now here, it's on the 24th today. It's on the 24th when I was recording this video, 24th June 2021, and it's at 9:45 p.m. So I can come here and change. So the second one, I will erase that. We're in June, so I type 6, 24th. So I type 24. It's 9. If I click once again here, it's 9:46. Well, I can come and put that. So I can come here and put it's 9:46 p.m. So I'm going to enter 21. I'm going to put, let me put 47 here, though it's 46, but yeah, that's fine with it. Go ahead and save that file. Save. After saving, you have to upload the saved one. So I will, so, and you'll see down here, it's only saving that single file that I edited. And then, boom, so it corrected it. And if you want to know, you can come here. I can come and copy this file. And if you go to the bottom here, you can paste it. And when I enter, it's going to give the time. And it's still, yeah, it's 47. After a short while, of course, if you run it again, you can give it a few seconds and see. I'll paste it again so that we make sure that it's correct. Enter, it's still 47. So you see the difference here. So after the minute, this is a second. So you see this was 24 at the bottom here. Then the one I entered after is 44. So after a few seconds, if I paste it a second time, I mean a third time, and I enter, it has already turned to 48. So as we speak right now, the microcontroller is recording the correct time. So make sure you have it set before you do anything. So we are done with setting the real-time clock. The next step is to go to the deep sleep. We want to now test the deep sleep. And I mentioned that the deep sleep is meant to save on battery charge. I showed you, if you remember, I will show you again. Just a minute, I will show you. This is a low-before battery that you install in the field. And this battery, this is a 2000 milliamp battery. If it runs continuously, it would only last for about 2 days. But because we're using the deep sleep that wakes up for about 1 second, takes measurements and goes to sleep, it can run for up to 3 years. So you see the value of deep sleep. Okay, let's go ahead and implement the deep sleep. I will move back and I'll open the Visual Studio Code. I will close this. Because we'll be running it in the same microcontroller that is connected, I will move ahead and open the folder that has a script for that. And here we have the deep sleep. I will select it, that folder. And the next step, of course, once we've selected it, would be to upload it. So go ahead and upload them. Once it uploads, you'll see that it will start running. The reason why it has started running is because we have the boot.py. So the moment you power it on and start the system and upload all the files, automatically it will start running. And you can see from the script here, you can see that it says wake up reasons. So that's the reason why it's waking up. And then right now it's on sleep. Then it wakes up again. And after it takes the measurements or whatever it is, and in this case we are only giving the instructions, as you can see from the script here, that we are giving it instructions to run the green, yellow and red. I will switch and you will see. So right now the microcontroller is on deep sleep. After 20 seconds it's going to wake up and you will see. Just give it a few seconds. There it goes. It has started. And the instructions I gave it was to light the red, green and yellow. Then it goes to sleep once again. And because I've set the time to 20 seconds, after 20 seconds, as you can see here, if I want to alter the time, I will need to change the script. Let's wait for it once more for about 20 seconds and and there it goes, and it goes on. To end this, I will use the Control C. Remember, I mentioned that if you want to stop a script, you have to use Control C. That's what I'm going to do. But remember one thing, while it's on deep sleep, you cannot stop the script from running. You have to wait when it wakes up. So I'm going to wait the moment it wakes up. Like right now it's running, so I'm going to use a Control C. Now it's gone to sleep. You need to make sure you put the cursor here. So I'll put the cursor there and wait for it to wake up, then I can apply the Control C. Yeah, so you see, when I type the Control C, it interrupted. That's how to stop the script. So I've been able to demonstrate to you how to implement the deep sleep concept. Let's go back to the slide. So we've been able to implement the deep sleep. And something that I forgot to mention was that the one we've just implemented was a fixed time interval. So we set it to 20 seconds. So every after 20 seconds, it wakes up. That's a fixed time interval approach of entering into the deep sleep. The second approach that we are going to demonstrate is the action of an interrupt. During the presentation, during the discussions, I mentioned that the fixed time interval only applies for variables that are continuous in nature, such as temperature, humidity. But for the variables that are not continuous in nature, such as precipitation, because precipitation is not continuous, it happens and then disappears, we use the action of an interrupt. So if the system or the microcontroller is asleep and then a rainfall event occurs, then it should be able to go to the microcontroller. That effect of receiving rainfall should interrupt the sleep of the microcontroller. I'll demonstrate how to do that. So I will minimize this and I'll open the microcontroller once again, the Visual Studio Code, and I will navigate to the folder that contains the files. And in Module 7 folder, there's a push button, an LED and LED expansion board. I'll select it. And as usual, the next step after selecting a folder would be to upload the scripts. But first of all, check and make sure that the connection is right. This one says that it's connected to COM3, which is wrong. We're still connected to COM7. So I will go ahead and select the project settings and edit this to 7. I'm going to close it and save it. Once again, select connect, and bam, it's connected. So the next step would be to upload. I will upload, which means I'm going to remove the previous deep sleep files. So it's removing, and the next thing, it's uploading the ones for the new interruption. Then now I'll demonstrate to you what is happening. So we have it here. We've connected it. As you can see, let me lift it. And this time round, we notice that this button, the LED, is brighter than before, which means it's on deep sleep, awaiting an interruption. And how do we interrupt? In the event, like for example, if we have this microcontroller connected to a rain gauge, a tipping bucket, then when it rains, the first drop that goes into the rain gauge should be able to wake this up. And how does that happen? We have to make some connection that will come and interrupt this from the sleep. But for this demonstration, the button that we are going to use to interrupt it from the deep sleep would be the S1. Check on your expansion board. You'll see there's a button next to in this line with the LED light. Immediately after the LED light, there's a button written S1. And this button is connected to a pin. So if we have a rain gauge, and when the tipping occurs, it should be able to come and connect to a pin linked to this one. to the S1, but because we don't have the pin in this case, we are going to use the S1 to interrupt it from the sleep. So I'll go ahead and press it. It goes off, so which means it has received an interruption. I'll go back to the, and if you go to the Visual Studio Code, you can see there it says that it got an interrupt at pin 10. So the S1 is linked to pin 10. So by pressing S1, it's the equivalent of sending some information through pin 10. So in case we have a rain gauge and the tipping bucket rain gauge has tipped, it's sending some signal to pin 10, which sends information to interrupt it, and that's why it wakes up. Then once again, when I press it, it goes on. When I press again, you see it says got an interrupt. So you see nothing. So the microcontroller will remain in deep sleep as long as there's no interrupt until an event occurs that sends some information in the form of data to make it wake up. So that's it, and let's go and check once again. So we've managed to cover the two options. That is, in this exercise we've covered the keeping time concept, then we've covered the deep sleep, and then we've covered, and in deep sleep we've covered two approaches. We've covered the fixed time interval, and we've covered the action of an interruption. So that's all from this exercise. Thanks, and see you in the next exercise.